tangent lines. Firstly, I will give you geometrical ideas what tangent lines are on a few pictures. So if we have a curve y equals f(x), and if I sketch a graph of it, and I pick a point on a curve, say somewhere here, point P, then the tangent line to the curve at a given point will be a line which will be touching the curve at this point, just barely touching it. Something which looks like this. If I pick another point, Q on the curve, then I can draw another tangent line to the curve at the point Q and looks something like this. So that's nice geometric interpretation what the tangent line is. So we'll be interested in how to find equation of a tangent line. The tangent line to the curve at given point P, and point P will have coordinates of x and f of x. Interesting? The trouble is, if you look again at the picture which we just drew, we have point P. The trouble is we have only one point, and we want to get equation of a line through a given point. That's a little bit troubling because in order to get equation of a line, we need to have 2 points. So let's see how we'll go about it. So if point P has coordinates x and y, where y is f of x, and then what we'll do is we're going to pick point nearby, and it's going to have coordinates x plus h and f of x plus h. Now we have 2 points, our original part and point nearby, and through these 2 points we can draw so-called secant line for these 2 points. The whole idea is based on the fact that our tangent line, which looks something probably like this, let's have a tangent line, and this one is our secant line. They will be kind of close if you look at the picture, but be kind of close. So the idea will be find equation of secant line, make that h smaller and smaller and smaller, and when h will be getting toward 0, secant line will be getting toward the tangent line. That will be an idea. So let me illustrate that idea on an example of a simple curve y equals x squared, by picking a point and doing calculation and finding equation of the tangent line. So let's see how we might go about it. So find, let's put it this way, slope, slope intercept equation for the tangent line to simple curve y equals x squared at point when x equals to 1. So we remember the graph of y equals x squared, that is a parabola. We have our point with coordinates 1, and y is also 1 because y equals 1 squared. So we pick a point nearby. It's going to have y x coordinate y plus h, and it's going to have y coordinate because of our function 1 plus h squared. So we have 2 points. For these 2 points, we can get equation of secant line. And so, if you're looking for secant line, we have 2 points, 1, 1, and 1 plus h, and 1 plus h squared. So we have secant line. For secant line, we have 2 points, so we should be able to find slope of secant line. I'm going to be writing slope of secant line. Rise for run. Run will be 1 plus h minus 1. Rise will be 1 plus h squared minus 1. We do our actual calculations. We want to simplify that expression. On the very bottom, we're going to get h. On the top, after the squaring 1 plus h squared, we're going to get 1 plus 2h plus h squared minus 1. Combining like terms, 1 minus 1 equals to 0. So, we get expression for slope of secant line. We can factor h out, so 2 plus h, and this h cancels out. So we have nice expression for slope of secant line is 2 plus h. Now if you recall how to from secant line get the tangent line, what we do is, if h would become 0, then secant line, slope of secant line will become slope of tangent, and slope of tangent, because h goes to 0, smaller and smaller and smaller, so in this case we get equals to 2. So we get the slope of tangent. And also you recall from our original one, we know that x equals 1, so y equals to 1, so we also know point 1 and 1. So using these 2 pieces of information, slope of tangent equals 2 and the point 1, 1, we get an equation of our tangent line. So the tangent line, whatever is your favorite way of finding the equation of tangent line, if you know point and slope, but make sure that it's a slope intercept for y equals 2x plus 1. That's going to be our final answer for this particular example.